Section 3.4 is multiplication of whole numbers. So grade 3 students are going to start developing an understanding of the meanings of multiplication and division of whole numbers through activities involving equal-sized groups, arrays, and area models, multiplication as finding an unknown product, division as finding an unknown factor. For equal-sized group situations, we can think of division as finding the unknown number of groups or the unknown group size. And students are going to use properties of operations to calculate products of whole numbers using increasingly sophisticated strategies based on these properties to solve multiplication and division problems involving single-digit factors. By comparing a variety of solution strategies, students learn the relationship between multiplication and division. Okay, so our goal here today is to look at these solution strategies. Okay, so we're going to start with multiplying small numbers. So repeated addition model, we're going to think of multiplication as repeatedly adding the multiplicand multiplier times. So if I wanted to do 4 groups of 3 brushes, I could use addition to put my 4 groups together. So I can think of this as combining 4 sets of 3 objects into a single set. And so I'm going to add those 4 threes. So I'm going to add 3 4 times to get 12. And so that tells me that, 4 times 3 is equal to 12. Okay, so we're going to interpret as this number is going to tell you, the first number is going to tell you how many times we want to repeatedly add the second number. Here are some more illustrations of the repeated addition model. We saw these blocks when we did addition, right? So if I wanted to do 5 times 4, I'm going to add 4 5 times. So here I've laid out the size 4 blocks 5 times, and you can match those with 2 10 blocks. So that must mean that 5 times 4 is 20. And again, we could use the number line. Here on my number line, I'm going every 4, and I'm going to do that 5 times. So 5 times 4 again is 20. All right, in general, and I've written it backwards here, we're going to interpret this as n times a is telling us to add a n times. Okay, so that's the repeated addition model. The area or array model is going to illustrate multiplication as constructing an array of crossed sticks or a grid and counting intersection points with the cross sticks or grid components with the grid. Okay, so here I'm doing 4 times 5. You can see on the left with the sticks, I've drawn 4 sticks going horizontally and 5 sticks going vertically. And if I count all the intersection points, I get that there are 20 intersection points. This is the array. And on the right-hand side of your screen, you have the area model. The only difference here is now I'm going to draw a grid. So I have 4 rows and 5 columns in my grid. And now I'm going to count the boxes inside my grid. So I'm not counting intersection points. I'm counting actually where these dots are in the boxes. And there are 20 boxes there. So 4 times 5 is 20. The Cartesian product model is going to help us think of multiplication in terms of our Cartesian products. So let's look at an example. Let's suppose that we're going to take 2 web-based courses. You can take either world history or ancient history for your first course. And then for your second course, you're going to take one of 3 languages, either Latin, French, or German. So I can use a tree diagram to help illustrate the number of different schedules. So I'm going to abbreviate these courses just so I don't have to write them all out. So history's courses are going to be WH and AH, and then my languages are L, F, and G. So here's my tree diagram. First, I'm going to choose my history course. So I could either choose world history or what was it, ancient history. And then I can choose a language after that. And so we saw this when we did Cartesian products, right? These are my ordered pairs that look like a history class and then a language. And we just count how many ordered pairs do we have. There are 6. I had 2 history classes to choose from and 3 language classes to choose from. So this is 2 times 3. And so in general, we're going to define multiplication of whole numbers in terms of the sets again. Remember when we defined addition, we used sets as well. And so same idea here. So if I've got finite sets, A and B, where the number of elements in A is little a and the number of elements in B is little b, then I'm going to define little a times little b to be the product of the number of elements of A times the number of elements in B. And so we're going to define that to be the number of elements in the cross product A cross B. Okay. In this definition, our sets don't have to be disjoint. Remember when we saw examples with cross products, we did some that were not disjoint sets. The expression A times B is called the product of A and B are called factors. Okay, remember again that this notation is used for the Cartesian product. So we can say A cross B, but it is not A times B when we're talking about the capital letters that represent sets. Okay, we don't multiply sets.